Today, lesson 47b, we continue with the topic of conversation, which has been proportional relationships. But today, we put the finishing touches on this with equations. Now, we're still going to go through all of the different things that we've talked about. And we will continue to use the correct vocabulary, proportional relationship, equivalent ratios, constant of proportionality, which sometimes I've referred to as a constant multiplier, which is really what it is. All right, so let's go ahead and get started. Let's just go ahead and start with number one. Here I have a table, and this table shows 3 measurements of a specific type of bamboo. Comparing the height to the amount of time it took to grow that height. So at 2 days, the bamboo height in centimeters was 120 centimeters. At 3 days, it was 180 centimeters. At 6 days, it was 360 centimeters. So let's, first of all, what is the input? What is the output? And this is a continuation of yesterday. And once you figure that out, write it down off to the side. And remember, the reason why we're doing that is the correct way to check our ratios is output over input. Claire, what is the input? The time is the input. Very good. Which makes the height the output. If we know the time, we can figure out what the height is. All right. So now, every single problem today, we're going to be asking these questions right here. And they're all kind of laid out within each problem. But we're first of all going to ask or figure out whether it's a proportional relationship or not. And then if it is, what's the constant of proportionality? And if it is, what's the unit rate? And if it is, what do you know that graph should look like? And a lot of the problems that you are going to be graphing in addition. And then if it is, what is the equation? Now, if it's not a proportional relationship, then there is no constant of proportionality. And we know that what the graph will not have, we won't have a linear situation. And if we do have a linear, it won't go through the origin if it's not proportional. Now, we have found that sometimes we can still use an equation. It's just not a proportional equation. And I know that there's an area in your notes where you're supposed to be filling this stuff in right now. It's on the top of the right-hand side of your notes. And I should have mentioned that a minute or so ago, but I didn't realize it until I walked around and I looked. Okay, so I'm going to stop for a second to let you guys get that stuff filled in. Okay, so after you get that stuff filled in, then I want you to answer all of those questions for number one. Now, some of the problems in the notes, we are creating a graph. In number one, we're not creating a graph. If you're asked to create a graph, then you create the graph and then answer part D. If you don't have a graph like this one, then you'll just have to answer the question as it is. What do you know about the graph if you were to graph? So go ahead now and quickly answer all of those questions based on the information that we have in the table for number one. And I'll get back to you in about 2 minutes. So the first thing that we are asked to figure out is whether this is a proportional relationship or not. And there are several ways of figuring that out. One way is by checking the ratios of the output over the input. So we have 120 over 2, that's 60. We have 180 over 3, that's 60. We have 360 over 6, that is 60. Since all of those ratios of output over input are equivalent, and in fact they happen to be 60, that means that this is a proportional relationship. Now, the great thing about using output over input is that that is also the constant of proportionality. So here's another piece of information that we are adding, and this might be something that you add in your notes somewhere. K is typically, I guess it's already in your notes, you're just filling in blank areas. K is typically the variable we use to represent the constant of proportionality. So it's just another random variable that we use, so we don't have to write down constant of proportionality equals every single time. So in the problem that you're doing, k is equal to 60. And we can find k by finding the equivalent ratios like we just did as in the previous problem, or by locating the ordered pair 1 comma k on a graph. And I sort of hinted at this yesterday. So if you can find 1 comma something on your graph, that something is also the constant of proportionality. So the equation for a proportional relationship is of the form y equals kx, where k, once again, is the constant of proportionality. So if we know the constant of proportionality, there are a lot of ways of finding that, we instantly know the equation for that. So in this case, it would obviously be y equals 60x. And another way of finding it is doing the constant multiplier, which I just showed up there. 2 times 60 is 120, 3 times 60 is 180, and so on. So the constant of proportionality is k equals 60 for this problem. The unit rate is 60 centimeters per day. The numeric part of it is the constant of proportionality. And since the output is in centimeters and days is what we're referring to in terms of time, that's why, or how we get centimeters per day. Output per inputs. Next, since this is a proportional relationship, the graph would be linear and it should go through the origin. Now, I didn't make you graph that one, but if you did, that's what we would expect to see. A linear graph going through 0, 0. Next, part E. If I use h for height and t for time, now this is where you really need to be paying attention here, because one of the instructions in the homework, let me grab the homework, it says, if proportional, what is the equation that represents the situation? Use variables that make sense in the problem. Since the output is referring to height, it should make sense that we could use h, right? I mean, technically, we could use anything we wanted to, but h makes sense. And I'm using t for time. So use variables that make sense within the problem. So that means our equation would be h equals 60t. H equals 60t because of the variable choice that we made there. Okay? All right, so if the constant, just a quick review of equations. If we know the constant of proportionality is k equals 60, that means the equation is y equals 60x. If we know that the constant proportionality is 7, that would make the equation y equals 7x. If, and that's if we're using y and x, obviously. If the constant of proportionality is 4/5, the equation would be y equals 4/5 x. All right, so that should be obvious. All right, so for each of the following, you already filled in the blank areas there. You're going to find all of those things. So go ahead and do number 2 all the way through, and I can see from your notes in number 2, you are going to have to graph that one as well. So do all of those parts that you're supposed to find. So once again, you are determining if it's proportional first. Second, if it is, find the constant of proportionality. Then, if it is, find the unit rate. Then, if it is, in this one, you have to graph to prove that it's proportional. And then, if it is, write the equation using variables that make sense within the problem. All right, so number 2, this table gives the price for a different number of books. 3 books cost $12, 5 books at the same rate cost $20, and so on. I'm going to use the letters X and Y. I could use any letter that I want to. Obviously, the number of books is the input. The cost in dollars is the output. And one of the things we need to do, remember, is we need to label our axes. So since the number of books is the input, number of books goes on the, label the number of books on the x-axis, the cost on the y-axis. We don't have to think too much based on this table here. I think we can go by ones on the x-axis, and I believe we can go by twos on the y-axis. We've got to be able to fit all of those on our coordinate plane. And we talked about scaling yesterday. So 3, 12 leads here. 5, 20, and we talked about that yesterday. Now, I'm going to go ahead and connect everything together, okay? Because right now, we're not really thinking too much about that. But I did talk about the 8th grade standard yesterday, right? What is a reason why we really shouldn't connect those dots together with a line? What's a reason? Yeah. Yeah, you really, if you went to a store and you said, give me 1 3/4 books, right? That doesn't make any sense. So that's called a discrete relation. We really shouldn't connect them together, but I'm trying to make sure we get the idea of a proportional relationship down. So let's just go ahead and use our ruler and connect all those. So it's a linear relation here, linear graph, and it goes through the origin. So that's further proof that this is a proportional relationship. All right, line goes through the origin. And then the ratios, we're supposed to check the output over the input, not 12:3, which is what a few of you did. 12 over 3 is 4. 20 over 5 is 4. 32 over 8 is 4. The ratios are all equivalent to each other, so that's another reason why this is a proportional relationship. We could also constant multiplier, times 4, times 4, times 4, which is really where this comes from right here. Now, once we have that constant of proportionality, which is 4, k is equal to 4, we can now write our equation. Before we do that, the unit rate is, because this is one of the things you're supposed to find, the cost is $4 per book. We're supposed to answer all of those parts in A through E. There's the unit rate. And then our equation is, if we use y and x, y equals 4x. Now, one other question before we go on to number 3. What would the value of y be in 1, y for this scenario? Have a quick conversation with your shoulder partner. So the value of y would be 4. So if we zoomed in on the graph, 1, something is right here. That is 1, 4. But you shouldn't even need to look at your graph. If the constant of proportionality is 4, if the unit rate is $4 per book, once again, if the constant of proportionality is 4, if all the ratios of output over input simplify to 4, then it would be 1, 4. It has to be 1, 4. Okay? All right, so that takes care of number 1. Let's go to number 2. Number 3. I'm going to kind of help you with the input-output on this one, because in this one it's a little tougher to tell. The table shows 3 measurements of a special color of paint, comparing the number of cups of blue paint to red paint. So I'm going to tell you right now, the cups of red paint, that's the input. And the cups of blue paint, that is the output. Red is input, blue is output. Answer all of the questions, please. So I told you in number 3, cups of red will represent the input, and cups of blue, if we want to think of it that way, would be the output. And I'm going to use X and Y. You could use any variables you want to. You could use R for red and B for blue, whatever you want to do. As far as graphing goes, so cups of red is down there on the input or X-axis. We can go by 1s there, and it looks like we probably can go by 1s up the output or Y-axis. And I plot all of my ordered pairs, and we have a linear situation that goes through the origin. So that means it is proportional. We could check the ratios. The first ratio of output over input is 2/3. It's already reduced. The second one is 8/12, which reduces down to 2/3. The third one, 10/15, that reduces to 2/3. All of the ratios are equivalent. That's another reason why this is a proportional relationship. Now, that happens to be the constant of proportionality, which is the reason why we want to check output over input. So K is 2/3. That's the constant of proportionality. Next thing we were supposed to find was the unit rate. And that's kind of hard to phrase, but that means that there are 2/3 of a cup of blue paint per 1 cup of red paint. And that should say of of, not or. 2/3 of a cup of blue paint per 1 cup of red paint. That's the unit rate. And then our equation, since we know the constant of proportionality, and I'm using y and x, would be y equals 2/3 x. If you used r and b, it would be b equals 2/3 r. Here comes the same question again. What would the value of y be in 1 comma y for this scenario? If you look at the graph, it's kind of hard to tell because 1 is right here. You know, that's kind of hard to tell exactly where it is. Sometimes it's easy to see on the graph, sometimes not so easy. But based on what we talked about in the last problem, it should be easy. What's the value of y? Tell me, please. It's 2/3. Good. So it's 1 comma 2/3 for that ordered pair. We know that that has to be on the graph. Okay, here's what I want you to do, and I'm going to give you about 10 minutes. We're not going to do number 6. We are going to do number 4 and 5, so I want you to do all the parts of 4 and 5 with your shoulder partner, and I'll get back with you in about 8 to 10 minutes. 4 and 5. Number 4. That table represents or shows the 4 measurements of the amount of dirt excavated compared to the amount of time it took in hours. So hours is the input, and yards is the output. This time I'm not going to use x and y. I'm going to use h and y just because I want to. Hours, h, yards, y. And with our graph, we can go by ones. And when we plot our ordered pairs, we can clearly see we have a line that goes through the origin, so that means we have a proportional relationship. The constant of proportionality, lots of places to find it. You could find it with the ratios of 4/1 and 8/2 and 12/3 and 20/4. They all simplify to 4. You could also find it on the graph right here at 1 comma 4. You can also find it right there within the table. Lots of places to find that constant of proportionality. And the unit rate would be 4 yards per hour. And the equation using my variables would be y equals 4h. All right, number 5. Graph would look like this. We can go by ones on our scale. So we have 5 comma 1, 15 comma 3, 20 comma 4. We have a linear situation that goes through the origin, so we know it's proportional. As far as the ratios go, we have y over x, which is the output over the input, so we have 1/5, which is already simplified. Second one simplifies to 1/5. Third one simplifies to 1/5. So that's another way to tell that it is proportional, and that happens to be our constant of proportionality. So k is 1/5. The equation would be y equals 1/5 x. I didn't do a unit rate in this one because the unit rate would just be 1/5 like the constant proportionality because there's no really word problem situation that this is in. But I do have one more question. What would the value of y be for 1 comma y? Tell me, please. 1/5. It's 1/5. All right, I think you get that idea. Okay? All right, we are finished for today. Once again, we're not going to do number 6.